Already some basic idea you're having how to calculate the direction of friction. Whose help you have to take it? You have to take help of the relative velocity, no? So calculate the velocity of the disk with respect to board and the so disk. This is the disk. This is a board. This is a board, and this one is a disk. So we'll calculate the velocity of this now. Velocity of the disk with respect to board. What is the velocity of the disk is u. So 2I cap u bar minus v bar already has given symbol. So 2I cap minus of two j cap. Okay, this is how much now? 2I cap minus 2j cap. I'll let me make a simple diagram here for your convenient. See, power means not like only P equal to F into V. You may get a problem of different kind. So this is the velocity of the board V, and this is the velocity of this. So velocity of the disk with respect to board 2I cap minus j cap. So somewhere in this direction. And it should be opposite to this velocity of the board with respect to disk. Velocity of the board exactly opposite to this. So VBD, you write it. So what should be the VBD? VBD should be equal to minus of VDB. This should be equal to minus 2I cap plus 2j cap. That's what the diagram shows. How the friction should act? Friction should oppose relative motion. Should act opposite to this. So here on the board, the friction will be like this. The friction acting on the disk, it is. The friction acting on the board should be in this direction. Try to focus on application problem, just mere because maximum books they confined to some mathematical way of things, no? So maximum focus on application problems. We have this much here. So what is the magnitude of friction? F is equal to magnitude of both FD or FB. This should be equal to how much? Mu is how much? 0.2 into 2 into 10. 4 Newton. Okay, write down the expression for okay, now is asking the power. So we'll write expression for FFB, we'll write it. FB should be equal to 2I cap. So it will be 4 into cos 45 I cap minus sin 45 j cap. Why we are bringing? So what can be this angle? This should be 45 degrees. Looking at the vector, this should be the 45 degrees, no? So put it, this is 45 degrees. Okay, now you solve this one. So we'll get expression for friction on the board. Friction on the board is equal to 4 by root 2 I cap minus j cap. It should be opposite to this. 4 by root 2 minus I cap plus j cap. Now power this, let's come for, there's a basic thing. Calculate the power of frictional force applied on the disk and the force applied on the board. Okay, this one. And next again, at what rate it is being dissipated due to friction between the board and the disk. So there are two things are there. Who will move like this? The board and the disk, the external agent, no? How to calculate the power of frictional force applied on the disk and the force applied on the board. Applied on the disk and the force applied on the board. And what should be the external force on the disk? I have given enough information. Now you have to interpret that particular sentence. Calculate the power of external force applied on the disk and the force applied on the board. At what rate heat is being dissipated due to friction between the board and the disk. So there's a heat will be dissipated. No? So that is nothing but power due to friction, because friction is a dissipative force of that one. So heat dissipated should be equal to power okay, this one. So what is the power B? Power dissipated on the board. This should be equal to FB bar dot velocity of the board. Velocity of the board is how much? V only. I'm taking help of this symbol. What is the power? This one dot U bar. Okay, fine. So take help of the basic formulas now. So don't write power dissipated means FD into VdB. So what is the velocity of the disk? Velocity of the disk is U, no? And the velocity of the board is V. So take help of this. So like this, what happen? We'll get the power. So check this value, calculate. So you know angle between FB and this V, angle between the FD and this one. So we'll get this one. So this is about the heat dissipated. At what rate heat? What rate heat means the power dissipated. Rate of heat dissipated. There's nothing but the power only is asking. What about the calculate the power of external force applied on the disk? And the power of external force applied on the disk and force applied on the board. Okay, now how much of force I should apply on the disk to maintain that velocity U constant? Opposite to friction FD I should apply, no? Here. So that FD into U, FD dot U, FD dash, so you should assume a force opposite to FD, that one. Okay, clear. Then the velocity of the block U, the disk will remain constant. Okay, you should apply a force F1. If I write here, you'll get confused. So I'll write it separately here, this one. Is asking next, this is U. You have to apply a force. Capital letters, I'm showing that one. So because the friction is acting here, no? Opposite to that. Similarly, calculate the power of external force applied on the disk and the force applied on the board. The friction is acting here, the velocity should be constant. So on the board, what you should do? You should apply a force like this. So this is the otherwise what happen if you don't apply force, what will happen to the velocity of the board? Keeps on increases, no? He's asking this particular thing. Anyway, just calculate this. This is very important. Substitute these values. You can expect questions of application thing. So what we had earlier graph, no, power as a function of time, power as a function of distance, all they are typical questions. So maximum for advanced, no, you should focus more on numerical